Hi, Ecology Lab. I just want to do a little video here to show you to work through some of the things you're going to do for part 6 of lab number 6. So here I've got some example code. The code is all provided in the lab. It's in the appendix of the lab, so you have all this code. But I'm going to walk you through this and walk you through some of the finer points of this, so hopefully we can head off any problems. Okay, so the first thing you're going to do, looking at the code, we see we have a bunch of packages we have to read in. And so it says library vegan cluster, and ggplot2. So first thing, you need to make sure you have those installed on your computer. So if you remember, we go over here to packages and click install. And so for instance, I don't think vegan is installed right now here. So I'm going to type vegan and see it right here. And then I'm going to click install. And notice down here it says install.packages vegan, and it's doing a bunch of installation, and it's done. It says, all right, package vegan successfully unpacked. Great. I think the other ones are installed, so I'm just going to run these lines of code. So I'm going to run library vegan, and OK, library cluster, and OK, and library ggplot2. OK, very good. That's no problem. It was built under an older version, but it should still run just fine. Okay, the next thing I'm going to do is, because what you're going to do in part 6 is do a cluster analysis of your environmental data. Remember, in last week's lab, we did a cluster analysis of the taxon data to find plots with similar species composition. Now we're going to look at plots that have similar environmental characteristics. So what I'm doing here on line number 10 is I'm saying, okay, create an variable called envt. So that variable is going to be called envt, and into that I'm going to read.delim. So I'm going to read in this text tab delimited text file that I'm calling pitfall environment. If you need those data are here. You can download this file from World Class. It has tab 1 here in this Excel file is the taxonomic data, right? So these are the proportions of each taxon in each plot. The next tab is the pitfall environmental data, right? So the vegetation height, canopy cover, bare ground cover, and so on. And then the third tab is all the data. So we have both the taxonomic data and the environmental data. So you're going to need all three of those files in different ways. Okay, so here's what we're going to do. So let's read that in. I also added, this is a little different from previous ones, I added row.names equals 1. And what that's going to do, I'll show you. So let's run this. Oh no, we have a, oh, haha, look what I did. I forgot to set the working directory. So over here, I've got my files over here. And before you start, you should always set that as your working directory. Okay, so now it knows to look in this folder. And let's run that line. Okay, so it read that in. Notice over here in my data window, I have a new variable called envt. If I double click on that, here's all my data over here. Now by typing row.names equals 1, what that did is it made the row names for this data frame over here. So plot 1, plot 2, plot 3. So that's helpful. And notice my variables here, vegetation height, canopy cover, etc., etc. Okay. So we're looking good. So let's do a quick cluster analysis. So the first thing we have to do is create a distance matrix. So I'm creating a new variable called envt.dist, just to say that it's my distance matrix. I'm going to use the distance function. I'm going to do it on the data set envt, and I'm going to use the method Euclidean. And so if you remember, let's run that. What that does is it finds the similarities, or it finds the differences, the distances between points in that multi-dimensional space, right? So I have 11 variables. I have 11 different columns in that data set. It's going to find how different is each plot in that 11-dimensional space. Okay, so now let's do the cluster analysis. We're going to create a variable called dendro on line 16 here. Use the hclust function on the distance matrix, and we're going to use the ward method. Okay, that's done. So now we have a variable called dendro, and now let's plot it. So plot dendro, and here we go. And if I make this figure a little bigger, notice, so these are showing you how similar or different plots are based on their environmental characteristics, right? So plots 26 and 28 are very similar, and they're next most similar to 15 and 36, but they're very different from plot 1 and plot 38, which are over on the other side of the graph, right? So it shows us which ones are similar, but we don't know exactly how they're similar until we do some more investigating. Also, that row names equals 1. That puts those plot names down at the bottom of your graph instead of just numbers. Okay, so that's the first thing you need to do in, in part 6. The next thing asks you to do some exploratory analysis to try to figure out which of those environmental variables might be a good candidate for turning into a categorical variable. And so the way one of the ways that you can do this, and the way I'm recommending for this lab, is to just plot some histograms of the values. So if I pull up my environment data set up here, I can see all my variables here: vegetation height, canopy cover, bare ground, and so on. So all we have to do is down here in the console window, let's just make a histogram. So hist, and let's choose, so our data set is ENVT. We use the $sign to select one of the columns, and then we can see we can choose here. So let's choose vegetation height. And let's see there. Okay, so there's our histogram of that. So vegetation height, it's kind of a flat distribution, a little bit of a peak here. I wouldn't say that's particularly good for categorical because we've got kind of continuous values across there. Let's try another one. So hist ENVT $sign, and let's choose canopy cover. All right, let's see what that looks like. Oh, now here we have basically 0 to 20 %. So we have a lot of values, a lot of them with less than 20, and then we have a few with more than 20. So maybe here we could do something like, if it's less than 20% canopy cover, we can call that low, and anything above that we could say high, or something like that. Let's try again. Let's look at some of the other ones. Histogram, ENVT is my data set, $sign. Let's try grass. Okay, so grass, here, okay, so we've got a lot of values here, 0 to 20, and then we've got some on the higher end here, above 60. So we might say something like, oh, okay, we've got either low or high grass, and we could cut that off, I don't know, 40 or something like that. All right, so let's try that. So the next step, if we're just eyeballing this, this is all just exploratory analysis at this point. So let's say 40% grass is going to be our cutoff for low versus high. So let's go back to our data set here in Excel. And I'm in the All Data tab, so it has the taxonomic data plus the environment data. And so what I'm going to do is I'm going to insert a column right next to grass here. So right-click, insert, and I'm going to call it grass.hl for high and low. I don't know. You can call it whatever you want. And then I'm going to sort the data. Oh, wait, before I do that, let's get rid of that. First, I'm going to sort the data based on grass. So I'm going to go here to Data, Sort, and sort by, and I'm going to go down here to Grass, and I'm going to go smallest to largest. Okay. And so here we are. It's all sorted. Now I'm going to insert this column, insert, and I'm going to call this grass.hl for high and low. Okay. And then everything below 40, we're going to call low. So I'm going to just type low, low, and then I'm going to drag this down to, oops, I'm going to, tricky, okay, I'm going to drag this down to there, right? So everything below 40 is going to be low, everything 40 and above I'm going to call high. And drag that. So it's a little less than half of the plots are low grass, and about half the plots are high grass. So that's pretty good. Okay, so I'm going to resave this. Just save that. And now I'm going to save this as tab delimited text. So let's go File, Save As, Browse. And I'm going to call this pitfall.all, or full. It's the full data set. Again, you can call it whatever you want, just keep track. And it's tab delimited text. So let's save that. Okay. Let's go back to R, files. There it is, pitfall full. Okay, so we'll go back to our coding window here. And now I'm going to read that file in. Pitfall, read.delim, pitfall full.txt. So I'm creating a variable called pitfall, and that's going to have my full data set in it. So run that line. Okay, read it in. Let's take a look at it. So here it is. There's all my species data, or my taxon data. Here's all my environmental data, and notice we have this new one, grass HL, for high-low. Okay, great so far. So now let's run a model, and we're going to choose a taxon, and then you can choose any taxon and any environmental variable. But in this case, we did grass. So let's choose a taxon. I'm going to look at Collembola, because I think they like grass from what I remember of soil ecology. So let's do. I think we have a column called Collembola. Yeah, right here. So Collembola is the variable I'm going to use. So we're going to make a model, pitfall.model, LM for linear model. Pitfall's the data set, $, and we're going to put the column here, and that's going to be Collembola. Right there. Okay. And we're going to predict that based on grass. Right? You can really choose anything. Grass. And then we're going to see if that relationship changes based on whether it's high or low grass coverage. So let's do this. Grass HL. Okay. So there's our model. So let's run it. No errors. That's good. Okay. We can look at the summary, but first let's graph it. It's more fun to look at the graph than look at the summary output. So ggplot, our data here is called pitfall. And our model, our column name X is grass. Okay, our column name Y is Collembola. Make sure you spell everything correctly or you'll get an error. Let's see, and then we're going to color that graph based on grass HL. That's our interaction term. Grass.hl is what I called that. Okay, and then the rest of this, geom point, geom smooth, method lm, no problem. All right, let's run it, see what happens. And there's our graph. Okay, let's look at this. So here we have, these are offset because of course they're high and low. So here where we have low values of grass, we've got kind of a positive slope here. The fit doesn't look very good at all. Look, we've got points down here and points up here. The line is kind of through the middle. Where we have high amounts of grass, there doesn't seem to be. The slope is pretty flat, looks pretty close to 0. So anyway, let's interpret our output. So summary, summary is going to be the model name, which is called pitfall model. Pitfall model. And there's been some typos in some of the labs, but make sure when you're writing this code that summary starts with a lowercase s. If you type summary with a capital S, you get slightly different output, and that's not going to be what we want. So okay, summary with a lowercase s, pitfall model. Let's run that line, and here's our output up here. So we've seen something similar to this in the regression lab where you use the Shiny app. And again, so here's the intercept is right there. but we're more interested in the slope. So the slope is right here overall, right? So it's a negative slope, but the p-value is really high. So it's very close to 0, right? Not different from 0. Over here, this is if you have a pitfall, I'm sorry, your grass is low, right? So in these values over here, there's our slope, and again, not different from 0. And then here's pitfall grass over here. This is if you have a significant interaction, right? So does the relationship change? Is the slope of this one significantly different from the slope of this one? And it's not, right? Our p-value is high. The difference in slope is pretty small. Down here at the bottom, right, here's the multiple r squared, very low, 0.01. The adjusted is also very close to 0. So we see that the model fit isn't great here either. Don't worry, we're going to do more stuff with the, instead of looking at individual taxa, we're going to calculate some other measures of diversity. Hopefully we'll get some more interesting fits. But walk through this. This will show you how to do this for the, or this will kind of walk you through this for lab number 6. So if you run this code, you should be in good shape.